Lesson 3, getting into exponents. Lesson 2 was a lot of simplifying and evaluating, and now we're moving on to those powers. We start with our negative exponent rule. So a definition of x raised to the negative n. When we have a negative exponent, the good news is we can get rid of it by simply moving it up or down. The other one that I would add to this one is the fact that what do we do if we have 1 over x to the negative n? Now what do we do with it?
Move it up.
Yeah, you move it up, right? So understand it's not just a one-way street, but it goes both ways. So I like to add that one as well. They give us a number of examples here for number 1, all of them which I feel are really good. 1 over 3 to the negative second. There is our negative exponent again of 2. We want to get rid of it by moving it up on top. And as always, if we can simplify all the way, we're going to do so. B, we have 3 to the negative third. Again, negative exponent. You know, where is this 3 considered to be at right now? Is it on top or down below? It's considered to be on top, right? Okay. We don't have the ratio, don't have the fraction. It's considered to be on top. So therefore, we got to move it down below, move it to the denominator. And I do believe 3 cubed is 27. C is an interesting one. Negative 3 raised to the negative second. This goes back to the calculator idea before, because understand, if that parentheses is not there, this is understood to be like this. Okay? That negative is not a part of the base. So, when we move this thing now, the negative 1 can stay on top, but that 3 to the negative second now goes down below. So negative 1/9. Negative 3 in parentheses raised to the negative second power. Now it is in the parentheses. It's considered to be part of the base. Students will have a tendency to change this sign right here because we are programmed to think, oh, I got rid of the negative sign. Well, we did, but we only changed the sign of the exponent. It is not the base. So whatever the base is, leave it the way it is. And there's your difference again between getting negative and positive. And now Saxon is just playing with us. Negative 3 to the negative third. So, outside the parenthesis, so that is a negative 1. Negative 1 over, keep the base the same. So there it is. Negative 3 cubed. Negative 27. Negative 3 times negative 3 is 9, but when we take that positive 9 times negative 3, it again makes it negative. A lot of students will give me this for an answer. You know, it's okay, but understand 2 negatives are positive, so go ahead and give me a 1 over 27. Product rule for exponents. Simply put, if we have a common base and we're multiplying, we add the exponents. So m plus n. As we go about 2a, I always like to again identify the common bases. So an x, 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 and an x. If you want to rearrange those, that's fine. Otherwise, I just add the exponents the way they show. 2 and -5 will get me a sum of -3. -3 and 5 is 2. Plus 1 will get us 3. And then if we look at our y's, what's the exponent here?
1.
Yeah, so don't forget it. A lot of you will just end up writing -4, but it is 1 plus -4, which is -3. The other thing with this is a lot of you will give me this answer, and it's okay, but in math we really like to write the formal answer if we can. And to write it formally, we don't want the negative exponents. So x to the third over y to the third. I would prefer to see this one. The only time you write answers with a negative exponent is when you are dealing with scientific notation. For instance, if we have 2.07 times 10 to the -3rd, that is perfectly fine. B. Here's my advice. Simplify your numerators and simplify your denominators, then go from there. So if we just look at the top part, if we look at our x's, we got 4 and a -10 to get us a sum of -6. Y's. 5 and -3 will get me +2, plus this 1 here, so 3. Same idea for the denominator. Collect all those. -3 and 2 get me a sum of -1. -6 and 10 gets me a sum of 4. And now in this stage of the game, there's a couple different things you could do. Number one, you could get rid of your negative exponents by moving those, and that's the method I was going to do. Also, if you're good with your quotient rule and you like to subtract those exponents for the common bases, you could do that too. Well, let's go ahead and move them. And the way I like to do this is I just like to start with the first one and just ask myself for every one of them, do I have to move it? Do I have to move this one? Yes. Okay. It's negative, so it's got to go down below. Do I have to move this one? No, it's positive, so keep it on top. Do I have to move this one? Yes, so move it up above. Do I need to move this one? No. And at this point, 1x on top, 6 down below, so one of those pairs cancel out, leaving us with 5 x's down below. 3 y's on top, 1 y down below. And I believe, did I make a mistake somewhere? 4 y right here?
Down below.
Yes. And this should be a 3y, yes. Okay, 3 y's on top, 4 y's down below. Better. Avoid the Mr. Door trivial mistake. Let's talk about the power rule real quick. Power to a power, we are now going to multiply those exponents. Again, and doing them since, what, 7th grade? 6th grade? The only thing now is, instead of looking at more basic problems, we're looking at things like 3b. Lots of variables, am I right? Stick to your concepts though. If I have a power to a power, what do? Well, I multiply. So what do I get when I multiply a and b? Well, I simply get ab. What do I get when I multiply here? Well, what you get is y to the a times b plus 2 with parentheses around it, the quantity of b plus 2. I guess if you want to in this step, well, let's do this for now. We'll get there in a minute. Okay, distribute here, we can do that. Also in this step, if you would like to, what do we need to do with this negative a? Move it up. X to the positive a now. So the good news is our denominator has gone away. Isn't that nice? X's are common bases, so we can add those together. AB plus A, Y, AB plus 2A. These two are not like terms, these two are not like terms, so you cannot add those together. This is all we can do. Hang with me, we're getting closer. We are diving into some scientific notation problems. And look at that joyous expression they gave us there. Beautiful, right? Man, that was so nice of Saxon. 0.0003 times 10 to the negative 6 times 4,000 and so forth. Awesome. A couple of ways that you can go about it. I'm going to show you my method. The first thing we want to do is identify all of these numbers that are not in scientific notation. You know, if I look at this 0.0003, I want to express that as this number in scientific notation. So, let's do it. 3, you know, if I want to write the 3, 1, 2, 3, 4, it looks like that's equivalent to 3 times 10 to the negative 4th. Would you all agree? Okay? Now understand, scientific notation is no more than multiplying two numbers together. This is still a multiplication symbol. So, some of you may be asking, what do I do with that 10 to the negative 6th? Well, you just copy it down, and then we'll deal with it later on. If we go to the next one, 4,000 times 4 times 10 to the 1, 2, 3. Everybody okay with that idea? If we move on to the next one, 1, 2, 3, 6 times 10 to the negative 3rd. Don't forget this 10 to the 15th. And now we're back to 2,000. 1, 2, 3. 2 times 10 to the 3rd. So step number 1 for these problems are, yes, they're a mess. Takes a little bit of time. You need to be careful as you go through them. Make sure everything looks right. We still have this 10 to the negative 6, 10 to the 15th, 10 to the 4th. But are we seeing this in the colors? Now at this point it becomes relatively easier for us. 3 and 4, when we multiply those together, we get 12. And what do we do with all these powers? Add them, right? Because we're multiplying with a common base. So negative 4 and negative 6 will get us negative 10. Negative 10 plus 3 will get us negative 7. So that's good news to us. If we go down below, I have a 6 and I have a 2. Product again is 12. And if we add the exponents, Negative 3 and 4 will get me a positive 1, plus 15 will get me 16. Do we need to take a moment to let this digest? Everybody still on the same page? We're good? Okay. At this point, we can, 2 numbers on top, 2 numbers down below, multiplication sign in between. What's 12 over 12? 1, right? So are we okay with saying that these two cancel out to 1 and 1? Yeah, we do that all the time in math. So we have 1 times 10 to the negative 7th, and understand we want this number to be in scientific notation, so let's move this 10 to the 16th and move it up on top. So if I move it up on top, this is kind of the reverse negative exponent rule. This is not the way we typically go, but if I want to move this, what does that 16 become? Negative. And we are just about done. Let's see here. Mr. Dorr made a mistake, didn't he? What did I do? Negative 3 and 3 cancel out, right? 15 and 4 will get us not 16, but 19. So let's go and do this. Anybody see that? No. Gotta buy all of you, huh? What's that?
I thought maybe that we missed the 3, but I thought I was wrong, so I didn't say anything.
Negative 19. Now let's take 19 and 7 to get negative 26. We do one more problem. Speed of light. They're saying it's 3 times 10 to the 8 meters per second. If the moon is 3.844 times 10 to the 8th meters from Earth, how many seconds does it take light to reach the moon from the Earth? Awesome. There's a formula that if you have been taught, or I'm sure you've seen it before, and it goes distance is equal to rate times time. I would put that one in your notes. Distance is equal to rate times time. And that will be very, very helpful for you. Because at the end of the day, when you're attacking this problem, you're going to be telling yourself, okay, do I multiply these two numbers together or do I divide? If I divide, which one is my divider? Which one is my dividend? This formula will eliminate all that for you. Let's start with our distance. What is the distance? Yeah, it's the meters amount. So the distance, 3.844 times 10 to the 8th. So I'll plug that in for D. What does this thing represent? That is your rate. Comparison of 2 units. There's your key. And what we are solving for is that amount of time that it's going to take for it to reach the Earth. Or the moon, sorry. So how do I solve for t? Divide both sides by this. Now, what happens to our 10 to the 8th powers here? All of those cancel. So what we're looking at here is simply 3.844 over that 3. The approximate time that we come up with. If we divide 1.28.